1.7 constant rate of change, found on math book pages 66 to 69. A rate of change is a rate that describes how one quantity changes in relation to another. In a linear relationship, the rate of change between any two quantities is the same. A linear relationship has a constant rate of change. The word linear means a line when you were to draw it. So in order to have a straight line, it must have a constant rate of change. So I'm going to abbreviate this, constant rate of change. So it looks like the word croc, like a crocodile, but I will always read it as constant rate of change. Letter A. The table shows the number of miles the plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. So to get from 30 to 60, we're increasing by 30. To get from 60 to 90, I'm increasing by 30. From 90 to 120, I'm increasing by 30. The distance for the miles goes from 290 to 580, 580 to 870, and 870 to 1,160. So the difference of 580 and 290 is going to be adding 290. To get from 580 to 870, you're adding 290. To get from 870 to 1,160, you're adding 290. So this is showing that there is a rate of change because they're all going up by the same amount. To find the constant rate of change, we're going to take 290 and divide that by 30. 290 and 30, both of them you can take out a 10. 29 divided by 3. Well, a constant rate of change needs to have a denominator of 1. So to get from 3 to 1, I divide by 3. To get from 29 to 1, I divide by, to get from, because I divided the denominator by 3, I do the same thing to the numerator. So 29 divided by 3 gives me 9 and 2/3. So the constant rate of change in miles per minute is 9 and 2/3 miles per minute. Letter B. The table shows the number of students that buses can transport. Use the table to find the constant rate of change in students per school bus. So we have the number of buses goes from 2 to 3, 3 to 4, 4 to 5. Each time this is increasing by 1. Well, the number of students goes from 144 to 216, 216 to 288, and 288 to 360. So we need to find the difference of 216 and 144, which is adding 72. The difference of 288 and 288 and 216 is adding 72. And the difference of 280 to 360 is also adding 72. So because this is proportional, we can find the constant rate of change based on students per school bus. The number of students are increasing by 72 each time, divided by the number of school buses, which is 1. Well, that's actually already a unit rate, because you'll notice my denominator is already a 1. Sometimes that's very nice when it happens. So this means that our final answer is 72 students per school bus. Letter C. Use the graph to find the constant rate of change in miles per hour while driving in the city. Well, miles is going to be your y-axis. Hour is going to be your x-axis. So this is asking for your miles of y per hour, which is x. Well, we need to figure out the difference that we are increasing each time. So if I go up this distance, it is going to be 30. And I know that from my ordered pair being a y value of 30. The next one goes from 30 to 60, 60 to 90, so it's increasing by 30 every time. Then for my x values, it's increasing by 1 every time because we go from 1 to 2, 2 to 3. You can also look at the graph and see that horizontal value. So this is meaning for the constant rate of change that you are driving 30 miles per hour. And you can just write it as 30 mph. Letter D. On the lines below, explain what the points 0, 0 and 130 represent. Well, in this case, at 0, 0, you have traveled 0 miles at 0 minutes. You could also say that you have not traveled, no time has passed, so you haven't traveled at all. And then when we have the ordered pair 1, 30, that means that you have traveled 30 miles in 1 hour.